This is just a really great reference sheet. This is probably stuff that you know already, but just in case you've forgotten or it's been a while since you've taken MA 104 or trigonometry, here are some ideas or things to remember about different functions and where they are continuous. So polynomials, that's like a quadratic or a cubic function, etc. Those are continuous everywhere. There's never a point at which they are discontinuous. Rational functions are continuous except when the denominator is equal to 0. So make sure denominator does not equal 0 and you'll be okay. Radicals, we just got done talking about this one. Make sure that the radicand is greater than or equal to 0. So again, reals that are greater than or equal to our number, which makes the radicand 0, which in essence is saying make the radicand greater than or equal to 0, as we just did on our last example. Trigonometric equations, reals except for asymptotes that occur in tangent, cotangent, secant, and cosecant. And this gives us a reminder of where that is, again assuming a period of 2 pi. And then again, always verify with your calculator if you need to, but this gives you a nice idea of where those functions are continuous. Here are a few properties that are sort of nice to know. They're sort of commonsensical, so it's not something you'd have to memorize because you could really reason through these yourself. If we have a continuous function and we're multiplying it by something or adding something to it, then it's going to continue to be continuous. If we have two functions that are continuous and we're adding them together or dividing them, etc., we're going to have another continuous function. Continuity of a composite function, if you have two continuous functions and you compose them, that result is continuous. Here are some great ones for you to try, and I'm going to go through these with you, but it might not be a bad idea to press pause and try these questions first. Utilize your calculator if you'd like, utilize your brain, either way. And discuss the continuity of each of the functions below. So for the first one, I'm looking at x, which is continuous, 7, which is continuous, sine, which is continuous. So the first one is continuous everywhere. The second one, I'm dealing with a tangent function, and so that is not going to be continuous everywhere because we have asymptotes in the tangent function. And in this case, it would be continuous at pi over 2 plus pi times n for all of the integers n. Second one, h of x equals x over sine x. Again, because sine is in the denominator, we're looking at where does sine equal 0, and that would be at x equals pi n, so pi, 2 pi, 3 pi, etc. would be where my denominator is equal to 0. Cosine is a continuous function. There are no asymptotes. It does not matter that I'm multiplying it by 5. It is the same function. And then tangent of 1 over x is discontinuous at 1 over where it would normally be discontinuous just regularly. So we get the idea. Again, notice these two things are the same. I've just put one of them in the denominator since that's the denominator here.